Hello, today's lesson is going to start our unit on rational functions. And to start talking about rational functions, we're first going to talk about rational expressions. So, a rational expression is a ratio of two polynomial expressions. So remember that a ratio, it can be expressed like 2 to 1, but that's not what we're going to talk about. We're going to talk about ratios represented as fractions. So here are the steps to simplify a rational expression. You can write those down, but we're going to get to that more in just a minute. The first thing I want us to focus on is remembering how fractions work. So in this video, we're going to learn to simplify, multiply, and divide rational expressions. And first, though, we want to remember how to simplify, multiply, and divide fractions. Okay, so let's not start by adding a lot of letters. Let's just focus on what we already know. Okay, so if we wanted to simplify 20 over 8, most of you would just think in your head or do it in your calculator, and you would get 5 halves. But what you did was you divided each of those by 4. And 4 is the greatest common factor of 20 and 8. So to simplify a fraction, you just find the greatest common factor and divide the top and the bottom by that factor. Now, what about to multiply fractions? When we multiply fractions, we multiply across the top and across the bottom. So we're going to do 3 times 2 is 6, and 4 times 3 is 12. Then we need to simplify, and so we can divide both of these by 6. And get 1 over 2. So 1 half. Finally, I want us to look at division. And when we divide fractions, we multiply by the reciprocal. I think I spelled that right. We'll see. Okay, and so what that means is that we're going to turn this into 7/8. So you keep the first one the same, change this to multiplication, and flip the second one. I've also heard this called the KISS method, where you keep it, switch, and switch. So you keep the first fraction, switch the sign to multiplication, and switch the second fraction to its reciprocal. You flip it upside down. Okay, so then we just have multiplication, which is what we did in the last one. So we have 7 times 3 over 8 times 4, which gives us 21 over 32, and that is not a reducible fraction. So let's see what this looks like as we get into rational expressions. So the first one, we have been looking at these with polynomials. So in this past unit, we did radicals, but before that, we were doing polynomials. And we just want to simplify this, so don't overthink it. This one you should already know how to do. So 20 over 14 is going to reduce to 10 over 7. And then x to the 6th over x squared reduces to x to the 4th because we have to subtract the exponents. And that's all you do for number 1. So don't overthink it too much. Okay, number 3 is where things get a little bit different because you cannot touch this section or this section because it's not multiplication. So in order to simplify and reduce, you have to have products and division. So only multiplication, and then your fraction represents division. In this one, we have addition and subtraction. And so this is, these are their own sections. And so what we have to do is we first have to factor this. And so this is where our steps come in. So factor everything that can be factored. Remember factoring? That's so much fun. We love it. So when this, okay, time out. So the top, the exponent of the variable is just a 1, which means it's all factored out. Okay, so there's nothing we can do there. So the top is just going to stay as y plus 8. But the bottom has a y squared. So that means we have to check and see if there's any way we can break this apart into binomials. Or they're also called linear factors. So factor everything. When we have something that looks like this with a 1 as the coefficient for the squared term, we automatically get to start with our parentheses, and we want to find two numbers that multiply to get negative 48 and add to get positive 2. And remember, whenever this is a negative, they can subtract to get positive 2. So I'm going to use plus 8 and minus 6. Now, if we factored everything and there are no monomials, that means terms by themselves. But now we have eliminate common binomial factors. So y plus 8 is a factor. And if we look at this, we have 3 binomials and they're all being multiplied or divided together. So like if we were to say that A is equal to y plus 8 and B is equal to y minus 6, this would look like A over AB. And if we were looking at this, we would say we can cancel those A's and we would be left with 1 over B. But B is equal to y minus 6. So we have 1 over y minus 6. And that's actually your answer. But I did it this way because I want you to really visualize the fact that we cannot, for example, we cannot just cross out all these y's. That's not allowed. Over here, you can't do y and y. Nope, not allowed. If it has addition and subtraction connected to it, you cannot touch it unless the entire addition and subtraction is the same on the top. See that we had y plus 8 here, and that whole thing, y plus 8, is also on the bottom. So those got to cancel. And that left us with 1 over y minus 6. All right, so number 5 has a couple of things that we want to focus on. So there's going to be both of these things over here. The first thing we're supposed to do is factor everything that can be factored. Well, if we look at the bottom, 7 minus p, the exponent on p is just 1, so there's no way to factor that any further. So we just have 7 minus p. On the top, however, we have p squared minus 49. So remember that whenever we evaluate or whenever we factor the difference of two perfect squares, okay, so we've been working with radicals, so you should know by now that 49 is 7 squared. It's a perfect square. So when we have the difference of two perfect squares, we get the square root of this one, so p, plus the square root of this one, 7, times p minus 7, okay? So just, you need to, this is a rule that we need to remember and refresh our memories with. Now, if we look, we have 7 minus p and p minus 7. We probably are really itching to mark those out, but we cannot just mark it out and move on. You can't do it. So instead, what we're going to do is we're going to look at this rule down here and see what happens when you have a minus b over b minus a. If we were to have a minus b over b minus a, and we wanted to reduce this as much as we could, look at what happens if we take -1 as a greatest common factor out of the bottom. So b divided by -1 would be negative b, and negative a divided by -1 would be positive a. So we can see that if we multiply this back out, we would be right back where we started. So we didn't really change anything. We just wrote it differently. Well, whenever we have negative b and positive a, we can switch the order of those. So we're going to have a minus b over -1 times a minus b. So we just took the positive a and put it here and the negative b and put it here. We didn't actually change anything. Now we have a minus b over a minus b, and we can mark those out, but we're left with this -1, and 1 over -1 is just -1. So this rule says that a minus b over b minus a is equal to -1. So let's go back up here to our problem, and what we can do is we can mark this out and mark this out. They're going to cancel, but we have to put in a times -1. And that -1 can go in the numerator or denominator. It does not make a difference, but in this case, there's nothing left in the denominator. So we're going to have, p plus 7 times -1. And when we bring that down, that's going to equal -p minus 7. And that's going to be your final answer for number 5. For number 7, we have to look at a couple of different factoring things that we haven't looked at in a little while. So to factor the bottom is actually fairly simple. So we're going to just take out a greatest common factor first. So we'll take a 2 out, and that leaves us with n squared minus 1. And now we have the difference of perfect squares. Remember that 1 is a perfect square, and n squared is also a perfect square. So we're going to break that down even further into 2 times n plus 1 times n minus 1. And that's the square root of this and the square root of that. And you do it plus in one and minus in the other. So now let's look at the numerator. So in the numerator, we can factor out a 2 as a greatest common factor, but that leaves us with 3n squared plus 4n plus 1. Now, I'm actually going to go ahead because 2 is multiplied by all of this, and 2 is multiplied by all of this. So I'm going to cancel these 2's because there's nothing being added or subtracted from them. It's just out there by itself. So we can cancel them. Now, that means that it's not going to be here either. But now we have to look at 3n squared plus 4n plus 1. There are 2 ways to factor this. I'm going to refresh your memory on the way that we've already learned so that you can, remember how we've already done it in the past. And that's the x method, and I'm going to show you kind of a condensed version. So we make an x, and then you do a times c. So that's 3 times 1. 3 times 1 is 3. And then b, which is 4, goes in the bottom. Remember that quadratic functions are ax squared plus bx plus c. All right, so we have a times c and then b. And we want to multiply to get the top and add to get the bottom. So the numbers we're going to choose are 3 and 1. So then we bring down our first term, which was 3n squared, and then we put our 2 chosen terms as the middle terms. And then our last term comes down from the top. So our last term was plus 1. Then we take out a greatest common factor from both sides. And when there is not one, we always keep this sign, and we always use a 1 as a placeholder. And so we're going to find out that n plus 1 is one of our terms, and 3n plus 1 is the other term. So that's one way to factor this. But I'd like to show you a different method on the calculator. Okay, so this is a shortcut for factoring, and if this confuses you and you were good at the X method before, then just forget I'm saying this, but it can save you a little time if you can understand how it works. So here's what we're going to do. We are going to go to y equals, and we are going to graph the thing that we're trying to factor. So in our case, we're trying to factor this reduced version here, 3n squared plus 4n plus 1. But in our calculators, we're going to use x's. So we have 3x squared plus 4x plus 1. And then we hit graph. And if you remember, whenever we factor something, the way we factor it is to find the zeros, and our calculator will calculate those for us. So we are going to hit second and then trace, because that is the calc option. So second, trace to get to the calculate menu. And then we want to calculate a zero. We want to calculate where a zero falls. And it says, okay, I'm sorry. I think I lost connection there for a second. So to get to the calculate menu, we hit the second button and then we hit calculate, which is above trace. So when we hit second, trace, that brings us to this menu, and we choose option 2 because we want to calculate a zero. So now it says left bound, and it asks us, is this what you're looking, or it just has a question mark. I don't know why it's a question mark. It says left bound. So we need to go to the left of the zero, and zeros are where it crosses the x-axis. So anywhere to the left of the place it crosses the x-axis is fine. And we're going to hit enter, and then we're going to go to the right of the zero and hit enter twice. And it's going to show us that our function has a zero at negative 0.33333. Now here is the problem with doing this on a calculator. You have to recognize that that means negative 1/3. Like, that's on you. You got to figure that out, because if you type in negative 0.3333333 and then try to make it a fraction, it doesn't understand that it is repeating, and so it doesn't translate to 1/3. But it is. It's negative 1/3. So if we know that 1 0 of this is negative 1/3, so x equals negative 1/3. And to find a zero, you have to set a factor equal to 0. So we want to undo that step. We want to make this equal 0 again. So we'll multiply by 3. So we'll get 3x equals negative 1. And then we'll add 1. So we'll get 3x plus 1 equals 0, which means this is the linear factor that we had used to find that 0. So we're using n's, not x's. So we'll have 3n plus 1. Then to find the other factor, all you have to do is take 3n squared divided by 3n. That equals n. And then positive 1 divided by positive 1 is positive 1. And that's a shortcut to factoring. I know it didn't seem like a shortcut because I had to teach you how, but once you do it a couple times, it's much faster that way. All right, so we have now factored everything that can be factored, and you can see that we have multiplication of linear factors, multiplication of binomials. So n plus 1 and n plus 1 are in the top and the bottom, so we can cancel those both out. But 3n plus 1 and n minus 1 cannot be canceled. So they're going to carry down, and our answer for this problem is going to be 3n plus 1 over n minus 1. All right, so now we're into multiplying, and multiplying is not much different than simplifying. We just have to multiply first. So when we multiply fractions, we decided we multiply straight across. So 6 times 10 is 60. X squared times x cubed, we add the exponents, so we get x to the 5th. Y cubed times y to the 4th is y to the 7th, divided by 2 times 18 is 36. X squared, there's nothing else, so times 1 is just x squared. Y squared times y squared is y to the 4th. Now we reduce these, and we kind of take them as like separate sections. So we'll do the coefficients and then each variable. And we're going to get 60 over 36 is going to reduce to 5/3 because they are both divisible by 12. So 5 over 3. And then x to the 5th over x squared, we do 5 minus 2, which is 3. So we get x cubed. And then y to the 7th over y to the 4th, we do 7 minus 4, so we get y cubed. So your answer is 5x cubed y cubed over 3. All right, I'm going to do another multiplication example because this one is really long. So instead of multiplying this stuff together and then factoring it, we're going to factor first. So binomials and trinomials, we factor everything first and then simplify. Okay, that's just going to save you a ton of time in the end. So 4x squared minus 4x. We can take a 4x out because that's what they have in common. And we're left with x squared minus 1. And I think I might actually do this one a little bit differently just to kind of keep things organized. So let's label these A, B, C, and D. And so A is 4x squared minus 4x. So let's factor it all the way. So we can factor out 4x. And that leaves us with x squared. No, it doesn't. Just x minus 1. All right, so that one is factored. Now let's do B. 2x squared, squared, plus 4x minus 6. First, we can take out a 2. They all have a 2 in common. Now we want to factor this into two binomials. And we want numbers that multiply to get negative 3 and add to get positive 2. So I'm going to use plus 3 minus 1. And now that one is factored completely. So let's go to part C. X squared plus x minus 6. We want to multiply to get negative 6 and add to get positive 1. So we're going to get x plus 3 times x minus 2. And it's factored completely. So now for part D, we have 4x squared plus 8x. And we can take out of that a 4x. And that will leave us with x plus 2. All right, so each one is factored completely. Let's outline those real quick so that we can see them easily. And then we're going to just put them back where they belong. That's why we labeled them, so that we know where they go in this problem. All right, so when we rewrite this, we have A over B. So 4x times x minus 1 over x. Nope, see, I did the wrong order. Pay attention because you'll mess up like me. 2 times x plus 3 times x minus 1. All multiplied by C, which is x plus 3, x minus 2, over D, which is 4x times x plus 2. All right, so when we multiply these together, they just become one big fraction. So we're going to just kind of meld all this together, and this is multiplication between them. So now we can cancel across fractions. So x plus 3 is in the numerator here and in the denominator. X minus 1 is in the numerator and denominator. 4x is in the numerator and denominator. All right, now we want to look at what's left. We have x minus 2, x plus 2, and 2. So x minus 2 over 2 times x plus 2. Nothing else can be reduced, and so that is your final answer. Our next section is dividing rational expressions, but if you remember from the beginning of the video, when we divide fractions, which are just a really simple version of a rational expression, we multiply by the reciprocal. Okay, so all we have to do is keep it, switch, switch. So remember, keep it, switch, switch. And that's going to look like 5pq over 16p cubed times 8q to the 5th over 35p squared q squared. And now we are going to multiply everything together. So we're going to get 40p q to the 6th over 16 times 35 is 560. P to the 5th q squared. So 40 over 560 reduces to 9 over 14, and I am wrong. It reduces to 1 over 14. I apologize. So we're going to leave the top blank for now unless we need a placeholder. Then we have p over p to the 5th. Remember, we'll do 1 minus 4, and that gives us negative 4. All that negative means is that we're going to put it in the denominator. So it'll be p to the 4th, but in the denominator. Then q to the 6th over q squared is q to the 4th, and that will go up top. And that's it, guys. That's your answer. And this is the last example I'm going to do with you. So let's go ahead, and this one has 4 different sections that need to be factored. So I'm thinking, actually, I think we can factor them all in one step. Okay. So for the first section, 2a cubed minus 12a squared, we can take out a 2 and an a squared. That's going to leave us with a minus 6. Then in the bottom, we want to multiply to get negative 12 and add to get negative 4. So we're going to get a minus 6 times a plus 2. And then we're going to switch the sign to multiplication and then flip this fraction. So the numerator will now be this, and we're going to factor it to get a minus 5 times a minus 3 over, then factor this to get 8a squared on the outside times 3 minus a. There we go. All right. Remember, once it's multiplication, we can just pretend it's one big fraction, and this blank space is just too much space. All right, so we've got a minus 6 and a minus 6. We've got a squared and a squared. 2 over 8, like 2 over 8 reduces to 1/4. So I'm going to cancel the 2 and change the 8 to a 4. And then we have a minus 3 over 3 minus a. But remember, whenever it's subtraction and they're in the opposite order, we can cancel them, but we have to put a negative 1 in there. So sometimes when there's a lot of stuff going on, I like to go through and circle what I have left so I don't leave anything behind. So I've got a minus 5, negative 1, a plus 2, 4, and that's it. So let's rewrite this. A minus 5 times negative 1 over a plus 2 times 4. And we can distribute those out and get negative a plus 5 over 4a plus 8. Or you can leave this. If it's just a negative 1, go ahead and distribute it. But on the bottom, you're welcome to leave that as 4 times a plus 2. Either one is fine with me. All right, that's all. Thank you for listening.